So this is just a general video for solution stoichiometry. It includes a lot of things, all kinds of stoichiometry, but it's specifically comes from 12.6, which was solution stoichiometry. That's not what they call it in the book, but that's what I'm calling it. So you should have a copy of this form, and we can fill this out as we go along. So the first thing we got to do, since it is stoichiometry, we do need a balanced equation. So I got the skeleton equation here, so we just need to balance. And I'm seeing this 3 on the magnesium. Let me get the pen turned on. And I'm seeing just 1 here, so I'm going to put a 3 there. And I'm seeing a 2 on the phosphate, so I better have 2 phosphates. I'm going to put a 2 right there, which means now we've got 2 times 3, which would be 6 hydrogens. So I need a 3 times 2 to get the 6 on the hydrogens, and that's a 1 if you want to put it there, but it's not required. So there is the balanced equation. And this first problem here, part A, it says what mass of H2, so I'm trying to find mass of this, can be made from 13.7 grams of Mg, 13.7 grams. So we just need to, this is just straight stoichiometry like we were doing in January. We'll start with the magnesium, the given, 13.7 grams of magnesium. I draw my train tracks, is what they sometimes call this. I need the molar mass because I got to convert to moles, right? It's balanced equation, convert to moles, find over given, convert back to grams, or whatever we're doing. So we got the 13.7 grams of magnesium. I need the molar mass, which is 1 mole. Mg, which is 24.31 grams of Mg. And then my find over given, this is my find. That's my given. I'm going to put in 3 moles. Wait a minute. Huh. 3 moles H2 over 3 moles Mg. Right, so our grams of Mg have canceled, our moles of Mg are canceling. Our 3's actually will reduce to 1 and 1. And then I just need the molar mass of the H2, which is 2.02 grams of H2, 1 mole of H2. And now the moles of H2 are canceling, so I am ready to do the math. Get the calculator out here. So 13.7 divided by 24.31 times 2.02 equals, I get 1.138379268. I'm going to round that to 3 significant figures and do 1.14 grams of H2. So that takes care of my letter A. And then let's go on to letter B. I'm going to erase this down here, this up here, and we'll go on, to letter B. I'm going to change color on my pen because it's a new problem. What mass of Mg should react completely with 23.5 milliliters of 0.425 molar H3PO4. Remember that this 0.425 molar means moles per liter. You gotta just be, that's gotta be automatic, 0.425 moles per liter. So I'm gonna go back up here to the equation, and I'm gonna write in my 23.5 milliliters of 0.425 moles per liter. That's my given, and I'm trying to find the mass of the magnesium. So I'm going to need this milliliters into liters. So to get from milliliters to liters, I divide by 1,000. So 23.5 milliliters of H3PO4 times 1 liter over 1,000 milliliters H3PO4. Here, let's do this again. Now, we're not ready for that find over given step yet because we're still in liters and need to be in moles, right? Because it's convert to moles. So I'm going to use the 0.425 moles per liter, 0.425 moles H3PO4 per 1 liter. Now my liters of H3PO4 cancel. Now we're at moles of H3PO4. Now we do the find over given. We're looking for the magnesium. So 3 moles of Mg over 2 moles H3PO4. And then we need the more massive Mg, which we looked at earlier, was 24.31 grams per 1 mole Mg. Now moles of H3PO4 have canceled, the moles of Mg have canceled. So we got 23.5 times, or divided by 1,000, times 0.425 times 3 divided by 2 times 24.31. And if my math is correct, I get 0.364 grams of Mg. All right. I'm going to once again, wait a minute, is that on the next page also? Oh, no, it is not. I'll just write it at the top of this page. Let's go with, let's make this bigger. Okay, so we're wanting to make 1 liter of hydrogen gas at 45 degrees Celsius and a pressure of 0.89 atmospheres. 1 mass of Mg was required. So we're looking for grams of Mg. There's my find. And my given, I've got 1 liter, 45 degrees Celsius, 0.89 atmospheres. This is a gas law problem. I'm going to use, what is this? I'm going to use PV equals nRT. I need N, right? Because it's balanced equation, convert to moles. This is my given. I got to turn all that into moles somehow. So I've got N equals PV over RT. And P is 0.89 atmospheres. V is 1 liter. T is 45, but that's degrees Celsius, so we got to add 273 to that. And that's going to be 318, I do believe. And then R, of course, will be 0.0821 liter atmosphere per mole Kelvin. So we're going to solve for N first. N is 0.89, 1 liter, 0.0821 liter atmosphere per mole Kelvin, and 318 Kelvin. And everything's going to cancel except for moles, and I'm getting 0.0341 moles of H2 gas. That's my moles of gas, so I'm going to start there. That'll be my given, 0.0341 moles H2. I'm trying to find Mg. So 3 moles Mg over 3 moles of H2. Again, the 3's are going to reduce to 1 and 1. The moles of H2 are canceling. And then 24.31 grams Mg per 1 mole Mg. And let's see what we get here. I have to recalculate this one because I don't have it on the paper. Oops. 0.0341 times 24.31. I get 0.828,971, so 829 grams of Mg. It doesn't seem like very much, but remember when we did the experiment where we put the pieces of magnesium in the big long tube with the hydrochloric acid, we were using like way less than a gram at that point. So this is closer to a gram, so this is even more than what we were using, which is plenty for this. Okay, so we've got now on letter D, 200 milliliters of 0.110 molar H3PO4 is used. What is the concentration of the MgPO42 solution that is made? So it's we're starting with H3PO4. So let's clear up some of this stuff here. Yeah, I'll just get rid of it all. I'll rewrite it down here. So we got 2 H3PO4 plus 3 Mg, Mg3PO4, 2, excuse me, H2, 3 of those. 3 of those. So we got H3PO4, that's my information about that. So 200 milliliters. H3PO4 times 0.110 moles H3PO4 per liter. And then we're trying to find Mg3PO4, so that's my find, that's my given. So 1 mole Mg3PO4, 2 over 2 moles H3PO4. And then, do we need anything else at this point? Oh, 1 over 200 milliliters Mg3PO4 2. How do I know it's 200 milliliters? Because we didn't add any water. The Mg here is solid, so whatever volume of the H3PO4 we have will be the same volume for the Mg3PO4 which works out nice in this problem because we can just cancel the 200s. And so now it's just 0.110 moles of H3PO4 divided by 2 moles. Everything else is a 1, so 0.055 moles per liter is the answer. Okay. It doesn't always work out that nice. Sometimes they want to know the volume. They'll give you the molarity and they'll want the volume at the end. And we'll see another problem like that on the next video. So, hope this will get you started down that path and keep you from having to read a little bit. Not that reading is bad by any means, but feel free to read all you want. But this will help if you don't have time. See you on the next video.